Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is an answer to a question that was asked for me during a Software Architecture Principles learning program. This is our learning program for architects who have some experience, but who are typically thrown into the software architect role and then would like to come back and have a stronger basis, have stronger fundamentals, and understand more about what software architecture is really about and kind of build on top of this. And at the end of this course, I had a very interesting question from the audience. I had a few interesting questions, but one of them was really cool. And the question was, which are the top 3 mistakes that architects make, and particularly for an existing project? And honestly, this question kind of made me think very fast and come up immediately with a few ideas. So I'm not sure that this should be my top 3 in the next year or so, but I think I definitely came up with a few things that are worth discussing regarding architecture. And these should definitely be in my top 10 mistakes, but maybe we can find other top 3 mistakes that make more sense for architects. Anyway, I thought that this is a pretty interesting topic to discuss, and so let's get into it. The first one that I answered was architect through marketing. And what I mean by that is, as architects and as programmers, we are often bombarded with a lot of marketing, a lot of commercial and promotional information regarding various tools, various techniques, various particularly tools, right? And as we know, we developers love tools. So whenever there's a new tool, it's like, oh, so we have a new toy we can play out with. But the thing is, with architecture, just jumping on the marketing bandwagon will most of the times will not solve your problems. What happens most of the times is that the claims in marketing and commercial documentation and conferences is really cool. It brings up, the advantages of the technology, but it doesn't give you a strong enough information about the trade-offs. As an architect, you need to make sure that you figure out which are the trade-offs of that technology. And so it's quite bad to just go with, Microsoft launched X or AWS launched Y, and that will solve all our problems. You need to figure out more about the trade-offs, and the only way I know, there are a few ways to do that. One of them is to analyze things, but honestly, the best way to do that is to build a prototype that focuses on your use case. And of course, the next question is, we don't have time to do prototypes for everything, so what do we pick for prototypes? And that's where you need to judge a little bit and do and figure out which are the most likely candidates that will solve your problem. So for example, AWS Lambda, really cool technology. You can jump all in serverless with it. It solves a lot of problems, but they are also pretty open about their limitations. There's a limitation in terms of execution duration. There's a limitation in terms of memory. And there are some limitations in terms of storage. If it has only temporal storage or temporary storage, or storage that needs to be more permanent. So, and when you think about that, you also need to think about the fact that you are linking yourself with a platform, and it will be quite difficult to get away from the platform. Is this what you want? Maybe it is in some situations. It also gets a little bit more difficult to figure out for complex scenarios what happens in error cases when you are having infrastructure issues, and how can you identify them, because it's quite difficult to do that if you don't have direct access to the infrastructure, as it happens with AWS Lambda. And this is just an example. This is the kind of analysis that you should perform for a bunch of technologies. And yeah, so don't architect through marketing. Don't just pick the solutions that look good or that are sold to your CEO or CTO by well-versed salespeople or consultants. Figure out what is your use case, test it, prototype it, and only then decide whether to adopt it or not. This would be the best way to do this. And also, it might be interesting to think about being more conservative in terms of what tools and libraries you use. I always liked to use VN-1. So if I'm using, I don't know, Spring Boot, it has a new version, let's say it's version 12, I don't know exactly what version it is. I would rather use version 11 for a bit longer until we get version 12, and then we switch to version, well, to the next one. So it's really useful to be more conservative, and maybe I'm exaggerating a little bit, but I like to be even more conservative than that. All of my projects have make files. If I need to pack everything, I'd rather pack it into deb files, even if there are some native package structures, like in jars in Java or pips in Python. But I'd like to have them inside the deb file, because the deb file also gives me the dependencies and all that. And then if I need to, even if I need to deploy this on Docker, on Kubernetes, I'd rather have the old technology still in place, because that is tested and it stood the test of time, and we know what works and what doesn't, and you can find a lot of information when something doesn't work, and it's quite easy. Whereas if you just jump into Docker, okay, it has developed pretty quickly, and I think it's fair to say that nowadays it's pretty mature. But a few years ago, that wasn't the case, right? Right now, maybe Docker becomes more like the universal platform that we hope for. So this is the main idea in the first answer that I gave. Don't architect through marketing. Try to get away from the biases, from the sales speech. Learn to read through the lines. And here's something very important. When you look at marketing materials, look at what they don't say. This is, if you can figure out what they are not saying, or what they touch upon but kind of brush over, those are the minuses. Those are the trade-offs that you are making. This is how you can teach yourself to identify trade-offs. So, but sometimes it's a bit difficult. You need some experience to figure out what they are not telling you. But it might be a good thing to take into account. All right, second answer. Don't confuse simplicity with familiarity. All too often, we will jump into familiar solutions because we believe those are the simplest, but it's not necessarily true. More familiar solutions sometimes are more complicated than other solutions that are less familiar. One simple example here is in terms of design patterns, there's a design pattern called strategy, which I love. It's a very useful design pattern. And there are a bunch of implementations, but at least one of them uses objects. This is a very familiar style, right? You have a base class strategy and then you implement different strategies in derived classes, for example, sort. Like that would be an example. You have sort algorithm and you have a base sort algorithm and then you have a bunch of derived classes that implement various types of sort. And then you can pass an instance of this object to another class in order to, for example, to a list class in order to sort itself. But the thing is, the simplest implementation of a strategy pattern is a function. It's a function that takes as parameters, two or a collection of things, an iterable of things, and gets out another iterable. That's basically it. And so that would be a simpler solution because it involves fewer elements. You don't have to write a class, you don't have to deal with inheritance, you don't have to do a lot of things. Now, it doesn't really matter for this context because sort and algorithm, these types of algorithms, we kind of figured them out for a very long time. So it's no longer a big problem. But it might be an issue with other things. So, for example, let's say you are jumping into microservices or you want to do a REST API. What would be your technology of choice for implementing? If I'm telling you just do a REST API for appointments, for example. And one first answer would be your favorite MVC framework. Maybe Spring Boot, maybe, ASP.NET MVC or whatever. But do you really need an MVC framework to do a REST API? Really? Isn't it enough to just have some functions that are mapped to some requests, and that's basically it? Some cases, it might actually be a much simpler solution. In others, maybe you need a full MVC framework to deal with that. So this is an example of, and I see it a lot with people confusing simplicity with familiarity. Functional constructs in your programming language. These are another example. Many of the things that you do with a for loop, you probably can do through functional constructs in your programming language, and they will be much easier, much simpler, because they involve fewer elements. You just call a function instead of going through the for loop. But it's more familiar to do the for loop. So now there's always a tension between these two when you make decisions that affect multiple teams, because in some situations they might actually have a hard time adapting to this, and so you need to make sure that they understand and learn these unfamiliar practices or constructs. But on the other hand, simplicity will help all of you develop faster, reduce the number of bugs, and so on. So it's quite interesting to think about this. The way designers in general, except software, deal with this is by doing multiple prototypes for the same problem and multiple prototypes that are quite different in nature in order to explore the solution space. And in doing so, they get away from what's familiar and they iterate until they find something that is simple enough. Unfortunately, in software development, we don't do this nearly as much as we should. Code retreats are an excellent way of doing that, of practicing this mindset, because, or instead of going to a code retreat, you can do the same thing by taking one problem. Can be a simple problem. In code retreats, usually it's Conway's Game of Life, but you can pick something else. And then set some constraints on yourself. Different types of constraints. For example, avoid for loops, only use functional loops. Avoid direct method calls, only use events, and so on. So there's a bunch of things that you can try to get out of your feeling of familiarity and find different solutions that you can deploy, so they become more familiar, and then you can deploy in contexts when they are the simpler ones. And it makes even more sense at the architecture level, where many of the solutions affect a lot of people for a longer period of time. So it's quite useful to find the simplest solutions whenever possible. The third one that I came up with is keeping your architecture stagnant. Too often we assume that we start with a set of decisions and then we just follow them. But the truth is, software has to be soft, it has to be changeable, and this includes architecture. Some of the decisions you might be able to delay, to defer until you have more information. Not all of them, but some of them. And if you can defer some of these solutions, some of the problems for later on, you can also figure out better solutions usually, because you have more information. Another thing is that you learn more about the domain and about the problem as you move along. And so you should include this knowledge back into the architecture. This is what was the initial idea of technical debt, is something that happens to everybody. When you start based on the information you have, but then you solve a problem in a certain way, deploy it, and then you learn some more things, and your design, your structures, your architecture tends to stay behind. And you need to make some effort in order to bring it back up to the point of where you, to the things that you know. Another problem here is not listening to feedback from developers. Too often in large organizations, you have architects that are far too busy attending meetings and other things, and they build this blueprint and throw it at the developers, and then the developers struggle, and instead of sitting with them and listening to why they are struggling and maybe figuring out how to simplify the architecture, they just move on, assuming that that is the blueprint that developers will implement. And that's not always true and not the best approach. So you need to adapt your architecture to the changes that happen around you. Some of these changes are related to the changes in market, to competition, what the competition is doing, to your users, what they are needing and what they tell you they need, and so on. Some of these changes are technical in nature, like maybe there are new tools, new frameworks, new things that you could benefit from, or from learning. You learn something new, either technical or about the problem, and then you can figure out better ways of dealing with this, implementing solutions. So these were my top 3. I think I would add another one. Just now it came to me, which is don't copy large companies unless you have the same problems. Too often in this industry, we think that if Microsoft, Google, Facebook is doing something, then also we should do the same things because those are the best practices. But reality is most companies don't have the problems that Facebook, Google, Microsoft need to solve. These companies have huge scale. They have billions of people sometimes as users, or at least tens of millions. They have a lot of requests coming to their servers. They are the focus and attention of various hacker groups, including state actors. So there's a lot that they need to do in order to keep things running and to keep them running properly. If you just have, I don't know, 10,000 users, 50,000 users, you are nowhere near to the same scale as Microsoft, Google, or Facebook, or Netflix, right? So you need to think about solutions that are adapted specifically to your context, specifically to your product, to your teams, to your organization, to your scale, to your requirements for reliability, and so on. So you need to pay attention to these things as well. Don't blindly copy other companies. It doesn't work like that. Architecture is about finding the best solutions for your context. And this is one of the reasons why it's so hard, because actually Mark Richardson says this, and I don't remember the name of his co-writer. Their definition in the book Modern Software Architecture, I will leave the link in the description, is architecture is the stuff you can't Google. And basically this is it, right? It's about these things that are so contextual that you cannot copy from other companies. So yeah, these are my answers to the question of which are top 3 software architecture mistakes. Again, this was kind of a on the spot answer. I would probably find other architecture mistakes, but these are the ones that came in my mind the moment I heard this question. So I hope you find these interesting, and if you have ideas for any other software architecture mistakes, let me know. It's nice to have a conversation. We love comments, so let us know in a comment what you think, which are mistakes that you've seen, mistakes that you've made as a software architect. uh, or mistakes that you can imagine in software architecture. Thank you kindly for the view, and until next time, remember to think, design, and work smart.